Hello everyone, I am Decadet Jan Christopher Mobles, and together with my groupmates we are going to discuss a new topic which is just relevant to the previous one that we had last time. So previously we already have discussed about the principles of shift handling and the significance of the related terms. For this topic, we are going to explain the effects of the wind, the current, squat, and shallow water in ship handling while maintaining safety of navigation. So for today's topic, our intended learning outcome or the ILO of our topic is that at the end of the discussion, you will be able to explain the effects of external forces to the ship handling and maintaining safety of the ship. Now allow me to introduce my groupmates for they will be discussing the topic from this point.
Good day, everyone. I am Decadet Gisino, and my topic is all about external factors. So, what are some external factors? There are four types of external factors. First, the wind, current, squat, and shallow water. So, let me explain to you what are the meaning of these four external factors. So, wind. Wind is moving air and is caused by differences in air pressure within our atmosphere. So let's move to the current. Current are the horizontal movements of water from one location to another, while squat is the reduction of a vessel's keel clearance caused by the relative movement of the ship's hull through the surrounding body of water. And last is the shallow water. Water of such deep that surface waves are noticeable affected by the bottom topography, while typically this implies a water depth equivalent to less than half the wavelength. That's all for my topic. Thank you.
Specifically, what are some external forces? First, wind. Wind is nothing but moving air. The air movement is always from high pressure to low pressure areas. These are extremely steady winds that blow from subtropical high pressure areas towards the equatorial low pressure belt. Among the external forces, the effects of the wind is most important. Wind forces greatly affect the movement of the ship. When there is wind blowing on one side of high-sided ship, moving ahead, she will not move along the line of the intended course line, but rather drift towards the lee side of the ship.
In addition to that, we have to know about currents. Ocean current are the continuous, predictable, directional movement of seawater driven by gravity, wind, Coriolis effect, and water density. Ocean water moves in two directions, horizontally and vertically. Horizontal movements are referred to as currents, while vertical change are called upwelling or downwellings. If if a current is acting on one side of the ship, she will behave in the same manner. That that is, she will be moving diagonally in the direction where the current is sitting, although her heading is on the course steered. To attain the desired track, we make allowance for set to compensate for currents and allowance for leeway to compensate the wind.
Good afternoon, everyone. My name is Cadet Lucida, and my topic is all about relationship between wind, current, and behavior of the ship. Wind and current, wind and current are usually associated as both being force not under control of the ship. The two force have different effect on the ship. The effect of the wind with along the movement of the ship, and the current is the motion of organates of the current in the ship. If the ship is loading, the current is very strong because of loading ship. Thank you.
Good day, my fellow cadets. I'm the Cadet Joseph A. Snalos, and I will report the relationship of the wind, current, and the behavior of the ship. So first, quantitatively investigate the variation of unhindered speed over the ground for the different sizes of the ship. Second is reveal the differences of the wind and current impact on similar size of the ship's behavior. The third one is quantitatively analyze the wind and current impacts of the behavior of the ships of different sizes. The last one is propose a regression model to estimate the ship's behavior under wind and current impacts.
So, good morning. I'm the Cadet Lucernas and my topic is all about squat. So, today we will talk about what is squat. Squat is the reduction of vessel's keel clearance caused by the relative movement of the ship's hull through the surrounding body of a water. Compared with the neutral position, the hull sinks deeper into the water and at the same time will trim slightly. The squat effect is the hydrodynamic phenomenon by which a vessel moving quickly through the shallow water creates an area of lowered pressure that causes the ship to be closer to the seabed than would otherwise be expected. So, thank you.
Good day everyone, I'm the Cadet Lauro Jan Christian. I'm here to report about shallow water. Water of such depth that surface waves are noticeably affected by bottom topography. Typically, this implies a water depth equivalent to less than half the wavelength. The effects of shallow water on ship may vary. Shallow water affects the maneuverability of ships considerably. The limited water depth will change the pressure distribution around the vessel and lead to an increase in hydrodynamic forces. The maneuverability decreases which, amongst other things, manifests itself in a substantial increase in the turning circle of the vessel or the required bend radius. Example given, Una River.
I'm Cadet Mosqueda and I'm going to continue the report about the work of Group 3. How does the mentioned forces affect the safety of the ship handling? Regardless of the type of ship being handled, navigation is inevitably affected by forces external to the ship and beyond control. These forces include inertia, ang wind, waves, currents, of tides, interaction between vessels, shallow water effects and bank effects, the magnitude of and the influence that forces have on ship handling is dependent upon ship size, speed and draft, and upon the condition of the sea. Accident attribute to their influence occur from the time to time. For safety purposes, knowledge and the coordination of proper seamanship is truly vital to know these factors to establish safe and risk-free voyage.